All right, class, in section 6.1, we covered confidence intervals for the mean when the population standard deviation sigma is known. And now we'll cover confidence intervals for the population mean when the population standard deviation is unknown. So you'll notice that this section looks very similar to section 6.1. We're going to introduce a new distribution called the T distribution, and we're going to use the T distribution in place of the standard normal distribution. But basically, all the steps are exactly the same as what we did in section 2.1. We're just introducing a new distribution that we'll use to look up those critical values in the table. Okay, so when the population standard deviation is unknown, the sample size is less than 30, and the random variable is approximately normal, it follows a T distribution. And the T, so just like Z equals X bar minus mu over sigma over the square root of N, T equals X bar minus mu over S over the square root of N. So it's, as I said, it looks a lot like the standard normal distribution. We're just going to use a T distribution instead. And the critical values of T are denoted by TC. So basically, when we're looking these up, we're going to use, I'll show you how to do it looking it up in a table, but usually you'll just use Excel. So the T distribution is in Excel. And instead of using the Z distribution, we're just going to use a T distribution. Okay, so instead of using norm.dist, we're going to use T.dist. So some properties of the T distribution, the mean, median, and mode of the T distribution are 0. The T distribution is bell-shaped and symmetric about its mean. The total area under the T curve is 1 or 100%. So far, up until here, this sounds a lot like, exactly like a normal distribution. The difference is that the T distribution, the tails in the T distribution are thicker than those in the standard normal distribution. And the standard deviation of the T distribution varies with the sample size. So in the normal distribution, the standard deviation is always the same. But in the T distribution, the standard deviation of the distribution itself varies with the sample size and is greater than 1. The T distribution, it basically is a family of curves. So the standard normal distribution is the standard normal distribution, always just 1. The T distribution is a family of curves, each determined by a parameter called degrees of freedom. And the degrees of freedom are the number of free choices left after a sample statistics such as, this should say, such as the mean, X bar, is calculated. So when you use a T distribution to estimate a population mean, the degrees of freedom are equal to 1 less than the sample size. And the reason for that is that if I know n minus 1 of the values and I know the mean, I can get the missing value because if I sum all the values and divide by n, that's how I get X bar. So if I have all of the values but 1, then I can back calculate and figure out what the missing value is if I have n minus 1 values and X bar. So that's why there's 1 free choice left after, or sorry, n minus 1 free choices left after the mean is calculated. So for the population mean, for a T distribution to estimate a population mean, the degrees of freedom are n minus 1. So this is what the T looks like. So as the degrees of freedom increase, which basically means as n increases, the T distribution will approach the normal distribution. After the degrees of freedom become 30, so or a sample size of n for the population mean, a sample size of 31, the T distribution becomes very close to a normal distribution. So here is our standard normal curve down here in blue. And then you can see that for the t distribution, the tails are thicker. So it's kind of flattened out. Okay, so here are 5 degrees of freedom, and here are 2 degrees of freedom. Okay, so with 2 degrees of freedom, we can see that the tails are very thick. With 5 degrees of freedom, they get a little smaller. And the bigger that your sample size get, or the bigger that the degrees of freedom get, the closer that this will come to approximating a normal distribution. So we can use this distribution to create confidence intervals for the population mean when we don't know the variance. And so it's just like what we did in section 6.1, except we're using x bar minus e to x bar plus e as our interval, but e is tc over s over the square root of, or times s over the square root of n. So we replace the z with t. So we're getting these values from the t distribution instead of the normal distribution. And this is the sample standard deviation divided by the square root of n instead of sigma. So instead of using sigma here, we use s. So the difference is we replace z with c, and we replace sigma with s. Okay, and the confidence interval, so the probability that the confidence interval contains the actual mean mu is c when we take enough samples. Okay, so we're going to verify that sigma is not known, the sample is random, and the population is normal, or that n is greater than 30. And then we will identify the statistics n, x bar, and s. Okay, so x bar we can find by taking the sum of x over n. S we can find by taking the sum of the squared standard deviations, dividing by n minus 1. That's how I get the variance and taking the square root of that. And then we can find x bar using the average formula in Excel and the standard deviation using the standard deviation dot s for sample in Excel. The degrees of freedom will be n minus 1. And then we can use table 5 in the back of our textbook. We can use table 5, or again, I'll show you how to look these up in Excel, which is definitely an easier way to find them. And the margin of error is t times s over the square root of n. And then the left endpoint is x bar minus e, and the right endpoint of the confidence interval is x bar plus e. So how do we know which one to use? So if sigma is known, then if the population is normal or n is greater than or equal to 30, we'll use the standard normal distribution. Okay, and e will be z times sigma over the square root of n. If the population is normal or n is greater than 30, but sigma is not known, then we'll use a t distribution. And the error will be t, the margin of error will be t times s over the square root of n. And when we look up this t value, we use n minus 1 degrees of freedom. So that is the end of section 6.2. Okay, and we actually don't cover confidence intervals for proportions in this class. So that's all we cover. So let's go look at our how we do this, and let's look at the homework for 6.2. So first of all, though, let me go to the textbook and show you where the table is. So if we go into our ebook, okay, so table 4 is the standard normal table. So again, this is in Appendix B. So table 4 is the standard normal table. And if I go down to table 5 is the t distribution. And the way we look up values in this for a confidence interval. It actually has a special table for confidence intervals. So it does confidence intervals, left tail test, right tail test, or two tail test. This is for chapter 7, where we use these pieces, like which tail test it is. But for this section, we're using a confidence interval. So let's look at how the table works. So it gives us the level of confidence C and our degrees of freedom. So we're going to ignore this part, the one tail and the two tail. So the level of confidence. So if I wanted to do a 95% confidence interval and my N is 14, then my degrees of freedom, if my N is 15, my degrees of freedom would be 14. So I would go down here to where my degrees of freedom are 14. Here's the 95% confidence interval. Here it's the column in the middle. And then I would go to, if N is 15, my degrees of freedom would be 14. And my T value, my TC would be 2.145. So I would put this in 2.145 into my confidence interval formula, or into my error formula. Instead of Z, I would put in this. Okay, remember for the standard normal, the ZC for a 95% confidence interval is 1.96. So this is bigger because the T interval is wider. All right, so let's go do some of the homework. All right, so number 7, find the critical value for C equals 0.8 and a sample size of 24. So first of all, you go down here, and this is section 6.2. Okay, so we use T when sigma is unknown. Okay, so let's start with, just like we did here. So we would put in our confidence level C, and we need N. In order to get the TC, the critical value for with a t-test, we need two things. So for Z, we only needed C, but for T, we need two things, C and N. So if our C is 0.8 and our N is 24, I'm going to again show you two ways to do this. Okay, so first of all, we need to know the area in the left tail. Okay, and so the area in the left tail is 1 minus the confidence level divided by 2, right? So that the area in the left tail is 0.1. And then our TC, if I want to use Excel, I'm going to go equals T dot INV, T dot INV, and then I put in my probability. Oh, let me do also my degrees of freedom. So these are my degrees of freedom, and the degrees of freedom are N minus 1. Okay. So now my TC is going to be, I'm going to go equals T dot INV. I put in my probability, which is this one, 0.1, and my degrees of freedom. So put probability, comma, degrees of freedom. Okay, So it's t.inv and then the probability and then the degrees of freedom. So again, this probability, these degrees of freedom. So this one is, and they want it rounded to the nearest thousandths with its 3 decimal places, negative 1.319. Okay. And then let's look it up in the table. So I just want to show you they all match. So if t is 0.8, which is this first column, okay, and then, or sorry, my confidence level is 0.8, C is 0.8, and then T, or my degrees of freedom are 23, N is 24, so my degrees of freedom are 23. So I go here, 1.319. Oh, and I want it positive. Forgot that part. So we always want to report this as positive, so we can go equal, let's use the absolute value of this, ABS, the absolute value. Okay, and then I can also look it up in this table. Okay, it does the same thing. So sometimes it gives you this table and sometimes it doesn't. That's why I like to show you where it is in the textbook. But again, we go to 23, 1.319. So they all give us the same answer. Okay, and this should be positive. My bad. All right, next question. Find the margin of error for the given values of C, S, and N. Okay, so for number, let me insert a row here. I'm just going to right click and then go insert, and it puts a row in because this one was number 7. Okay. Number 8. Find the margin of error for the given values of C, S, and N. So we have our C, S, N. So C is 0.95. S is 2.4. N is 21. Okay, and then I need these two things. So I'm just going to copy this, but I'm going to have to update my formulas. Right, so my area and my left tail, this should be this 52. Right, so it should be 1 minus my C over 2. And then my degrees of freedom should be N minus 1, which they are. And then my TC is the absolute value of t.inv, the area, or the probability rather, and then the degrees of freedom. All right, so that's how we find T. We can also look it up in the table. So now N is 21, so my degrees of freedom are 20. And here it is for the 95% confidence interval, 2.086. 2.086, so those match. Okay, so you can get it from either place. And then my margin of error, remember, E is TC times S over the square root of N. Okay, so E equals TC times S divided by the square root of N. So my margin of error, again, TC times S divided by the square root of N. So it's, and they want this rounded to 1 decimal place. So it's 1.1. Okay, and then this next one wants us to construct a confidence interval for the mean using the t distribution. So I'm just going to copy this. Okay, so for number 9, we're going to now construct a confidence interval. So we need C 0.95. Oh, now I need X bar as well. So let me just go ahead. I'm going to insert a row here, insert, and I'm going to add in X bar. And X bar is 12.3. So the advantage of inserting it like I just did is it keeps these formulas correct. Right, what I'm putting in here is input. Okay, so the nice thing about this is it calculated my degrees of, oops, I didn't update stuff. C is 0.95, X bar is 12.3, S is 2, and N is 10. So the nice thing about this is it updates everything for me since I inserted that row to put that in. So this is all still correct. And then it's calculating my error, which is T times S over the square root of N. And now I just need my confidence interval. So remember, my confidence interval has 2 parts. So my lower, my upper. Okay, and my lower is X bar minus the error. X bar minus my error, and my upper is X bar plus my error. And so this goes from 10.9 to 13.7. Be careful on your quizzes. A lot of times it'll change the decimal points. So you might want to write a note in here to yourself and make it like a bright color so you don't forget, or bold it, like make it green or something that says check the number of decimal places. All right, so we can check that. And then the last question has given the confidence interval, find the margin of error and sample mean. And that's going to be the same way that we did it back here in section 6.1. So you guys already know how to do that part. All right, so that is the end of section 6.2, and that's the last part that we needed to know for chapter 6.